Every once in a while, a revolutionary product comes along. Today in 2023, the revolutionary product is large language models. More specifically, the emerging capabilities of large language models. Today, we're going to dive into these kind of magical things.
Emergent properties. Some AI systems are teaching themselves skills that they weren't expected to have. How this happens is not well understood. One Google AI program adapted on its own after it was prompted in the language of Bangladesh, which it was not trained to know.
It's something the small models just couldn't learn at all. And after model, it's over certain sizes, it suddenly catch up. Certainly know how to do this task. For example, if you ask a model arithmetics, small models just couldn't do anything. But when model have like over 100, 200 billion parameters, it suddenly can do arithmetics very, very well. This is something we have never seen before. So now people are really wondering why this happened, how this happened. And today we're going to dive in to all these things. After this video, you will have much better understanding and understand how magical these things is after today's video. I know AI is very hard to keep up now. There's new models, new things, new papers released every hour. So if you would like to stay informed, don't forget to subscribe this channel. I publish AI latest things every week. So perhaps we need to understand what is emergence. Emergence is when quantitative changes in the system result in qualitative changes in behavior. So what does this actually mean for large language models? And emerging and abilities that is emergent if it's not present in the small models, but it's present in large models. So this just means you couldn't find these kind of things, abilities in small models. To measure these kind of capabilities, we need to define the model scale. So the first way to measure model scale is the amount of compute. Usually a larger model you need to use a much more amount of compute to train your model. So this is the first metrics that we can measure a scale of model. Then second one is a model that's number of parameters. The more number of parameters means the bigger model it is. And the last one is the training data size. Even you have the same size of model, but if you train on different size of data, they will have different kind of capabilities. But in today's video, we're not gonna talk about training data size because most of large language models that train on the same data sets, which means their training data size is almost the same. And we're going to focus on first two things: amount of compute and model parameters. And they are actually usually very highly correlated. The larger your model is, the more amount of compute you use to train. So this can be interchangeable for our model size measurement. And what's the task that we want to use to measure emerging abilities? Because we need to know what kind of emerging abilities, right, that are there, right? So we will let the model to do many different tasks and see what kind of a task that small model couldn't do at all, but the big models could. So this is our setup. It's called few shot prompted tasks. So we will give the model one example of the task. Like this example is sentiment classification. We give the model movie review. This movie sucks, and we tell the model this means negative. And then we immediately ask the model to do the prediction for the review. I love this movie. So model just see one example without any explanation, and model need to perform the task. This is called one-shot learning. And if you give model two examples, we will call this two-shot learning. So other people call this in context learning. There's many different names for this kind of task. But this concept is simple. Just give model a few examples before asking model to do prediction. And how do you do this? Just feed all of this in the prompt. So this is a very common way now to use large language model. So we're going to use this as a test to different sizes of models, see how they perform. As for what kind of tasks that we use to test model, we're focusing on very difficult tasks, because if you ask model very easy task, a small model can already do very well. So you couldn't see emerging abilities. If you really want to find out these emerging abilities, you really need to have very difficult tasks. So we have a few data sets today. I'm not going to talk about every of them. So I'm only going to focus on these three. The truthful QA is one of it. It basically is make sure how models mimic human falsehoods. They will ask a lot of questions that normal humans will answer wrongly because they have the wrong assumption, a misconception of their questions. You want to know if a model can overcome this. And this is very hard questions, by the way. And another is grounded conceptual mappings. Model need to do some coordinate direction and a lot of like conception things. It's very difficult things as well. And last one is multitask language understanding, like math, history, law. All of these tasks that we're going to use to test model, they are very difficult. So first one is arithmetic. I think I don't have to explain this. And if you let these small models to do arithmetics, they couldn't do it as well as ADOR. Their performance is as bad as the random guess line. And you can see for a smaller model, like models smaller than 100 billion parameters, they just perform very, very bad. The accuracy is 0. But when you scale out the model size to over 100 billion, over even 500 billion parameters, it's starting to catch up. Certainly, it knows how to do arithmetic. Its accuracy jumped from 0 to almost 35, 40. This is amazing. This is something we have never seen before. Usually, if you do an NLP test, you will see a small model can do already very well. Even you increase the model size by 10, its accuracy maybe just on this task maybe will only increase 2%. But in this case, it's drastically improved. It's almost previously 0 and then 40%. Other things like IPA translated rate. It's also the same thing, 0% to almost 25%. Word on scramble, same thing. Persian QA, same thing. The baseline is random. Basically, you just randomly guess is 25%. And then model, if you scale out the model can do the accuracy 50%. Truthful QA we introduced a little bit earlier. These data say the same thing. You can see almost everything is the same. For this different task, small models couldn't do anything. It's just as bad as the random guess line. But when you scale out the model certainly can do so many different things, can do so well. This is what we call emergent abilities. And we really don't know why this happened. So some potential explanations is, first of all, when model perform this very difficult task, it needs to do multi-step reasoning. When you do multi-step reasoning, you need to come up with a multi-step. Like first, you need to come up with first your answer, and then use this answer as input to derive a secondary answer. And then third one, fourth one, you need to do multiple reasoning. So if your model is not deep enough, means you don't have enough layers, you won't be able to perform this. And larger model usually have much more layers, meaning they're deeper, so they are able to perform this kind of multi-step reasoning. I think this is a very sound explanation. Another explanation is big model have much better memorization capability. So you can memorize the word knowledge, and a lot of those tasks requires very intense word knowledge. So that's what big model can do very well. But I don't buy this explanation because I think small model couldn't memorize that well, but at least they can memorize to a certain extent. So they shouldn't perform like 0 or as bad as random guess line, right? So I just don't think big models the memorization argument makes sense. I think it's more likely to be like multi-step reasoning. You need to have multiple layers, neural network layers, so that you can keep abstracting your concept and then get your answer. And I think understanding this why model have emergent abilities is extremely important, because if we can know what makes model suddenly have these abilities, we can kind of create a much more efficient model. Maybe we use a much smaller model to still have the same emergent abilities. And if we can know this, maybe we can change our model architecture to make the model have more emergent abilities, because now still a lot of tasks the model couldn't do. If we can know what makes model have emergent capabilities, we will be able to change the model architecture. We will maybe change the training procedure, or increase the qualitative training data, all sorts sort of things. That basically is a path to AGI. I would say if you could figure out these things, you do a little bit of a modification, maybe GPT-5 will become much more powerful than GPT-4 because we have much better understanding of this. This is really still the early stage of this line of work. I believe more people will look into that more systematically, more mathematically, to explain why model have these emergent abilities. Something like why model certainly can learn a new language with just one example, right? But small model just couldn't do. So that's it for today. If you would like to receive more videos, don't forget to subscribe. Other than that, I will see you next time.